everyone, Assalamu alaikum. I'm Anmol Zehrah. I'm an AI engineer at Atomic Computing. And a little about me is that I have been working as an AI engineer for about a year now. And I have research publication in IEEE for deep learning comparative analysis. My final year project also got featured at national and international levels, and then it has now converted into a small startup, which is also incubated nationally. So, and at Atomic Computing, it's basically an AWS partner. So, I am working here to basically develop different solutions using the AI ML services that AWS offers. So, that is a little about me. Now, today we are going to be discussing a very interesting research paper, which is from a very recent publication of March 2025. And the paper goes about by the title of Towards Agentic Recommender System in the Era of Multimodal Large Language Models. So now, in this time and in these times, you're basically focusing on recommendation systems which also leverage the power of LLMs and are also agentic. So it's like one of the most, you can say, recent researches that we'll be discussing today. So let's begin by understanding why we need to, move beyond the traditional recommendation systems and why we need to, start adopting a more intelligent, more agentic one. So let's start with what traditional recommender systems offered, right? So historically, if we look at it, so recommender systems have always relied on have heavily relied on user item interaction data, like for example, clicking, ratings, or your past purchase history, right? And all of these systems, what they typically use is that they have an ID based or a collaborative filtering method, which we use to recommend anything, right? So normally what is happening is that they're making like one shot predictions. That basically means that they suggest items without any consideration of ongoing conversations. Oh, just a second, I think my screen is not sharing. Is my screen visible now? All right. Okay. So basically this is the paper that we're discussing. Okay, so let's start with why we need to understand or why we need to move beyond the traditional recommender systems that we have and start adopting more intelligent agentic systems, right? So if we look at the traditional recommendation systems that we had, so historically these recommender systems have always been dependent on user item interaction data, like for example any types of clicks, past purchase orders, ratings. So all of these systems, they had an ID based or collaborative filtering based method, right, which used to generate these recommendations. So they were based on just one shot predictions, and they would not have any kind of consideration towards any ongoing conversation, any context, or they will not be suited for evolving user goals, right? So if we talk about this, traditional systems are basically passive. So they're going to only respond when the user is taking an action, and they have like no way of holding a dialogue or adapting dynamically or holding a conversation, right? And then there are a lot of limitations that we have in the traditional recommendation systems. That means that there are like they're very rigid in nature, right? Like for example, your traditional recommendation systems, they do not have transparency, because the user will not know why something is being recommended. It's just using some calculation or some collaborative filtering or some cosine similarity on the back end, and it's just going to recommend you something, but you would never know the transparency behind it, that why it was recommended to you. And then they're not even flexible because they will not generalize well across different domains, or when some new users, new items, or new tasks are added, they won't be able to adapt to it. And there is also a very cold start scenario problem because such models, their long term preferences cannot change. And when we're talking about personalization, it is very important to have those preferences being updated as per the user. Now, if we come and discuss about what LLMs are, LLMs have basically, led to a paradigm shift. And how is that happening? Now, large language models are basically transforming how machines have been understanding and generating human like responses. And through this, we have like four very powerful capabilities which recommender systems can have by integrating LLMs. So, your recommendation system can start to reason. So, like, now they can interpret natural language, they can infer intent, and they can also understand the user goal. Similarly, for planning, they can map out, multi-step paths to, recommend. Like, for example, helping a user plan a trip, right? Then is multimodal perception. Now, they will not just be processing text, but they can also go with, different kinds of data like images, behavior patterns, sometimes even audio. And when we talk about tool use, that means that, our LLMs are strong enough to interact with search engines, with any third party APIs, with any other, any kind of databases, and they're going to fetch real time and accurate data. So with all these capabilities, LLMs can basically help recommender systems to, evolve into like very adaptive, very intelligent systems, right? And finally, like, our goal is to just move towards agentic recommender systems. So this brings us closer to, our main goal. Like, unlike traditional recommender systems, agentic systems are very autonomous. They will not wait for any user to act. So, they'll just initiate helpful suggestions themselves very proactively. Like, they're very adaptive because they are going to be learning over time from context and feedback from whatever is coming from the user. They're going to be keep learning from it. Then they also engage in heavy dialogue. So that means that, if there is any ambiguity or if there is any recommendation which is not as per the user preference, they're going to learn from that dialogue. They're going to learn from that conversation that they're having, and they're going to improve it real time, right? And what LLMs do is that, they are very explainable, right? They're telling users why something is being suggested, and that is increasing the trust and transparency. So now that we've basically seen the motivation why there was a need to evolve to, agentic based recommender systems. So let's just take a deeper dive into, some specific limitations that the current systems have that the LLMs are trying to overcome. So, LLM ARS is agentic recommender system. They're basically moving beyond the static recommendations into dynamic one, which will be more interactive and very more personalized. Now, if we go into more depth of why, like, because whenever we're conducting a research, in this research paper they have given more attention to that, why, what was the reason behind, moving away from traditional recommendation systems. So it is very important to understand the reason and the motivation and, the main purpose behind this research. So the very first limitation is that there is dependence on ID based and domain specific features, right? So most of the recommendation systems, they're built on structured data. Like, you have user ID, you have item ID, you have categorical features. So all these models, they basically struggle when they're exposed to new users, new items, or, sometimes even entirely new domains. So they also cannot incorporate, open domain knowledge or context, and that basically limits their, ability to understand new requests or understand, real world events. Then, it also has very poor transparency and interpretability. For example, your traditional models are like black boxes, right? So even if they're recommending something accurately, users will be, left wondering that why is this being recommended to me, right? So this will always make it hard for developers to debug, or for regulators to audit, and it's going to overall make it difficult to trust the system. Then we have minimal user interaction, because obviously it's not conversational, it's not two-way, right? So user interaction is just going to be one way here. Like you get a list of recommendations, and that's about it, right? There's no back and forth dialogue, there's no clarification, there is no way to explain your preferences more naturally. So this is basically limiting the depth of personalization that a particular system may offer. Then they also struggle to model dynamic long term preferences. So, user preferences can change over time. So they can shift like by season, by context, or maybe because of some previous experience. So traditional system will not be able to cater to these changes, right? Because they will be lacking memory, they won't be adapting continuously. So now let's look at why agentic AI systems are such a transformative concept. Okay, like why, if like as per the research paper, over the past few years, there has been a very huge rise in agentic AI, right? So there were they started off with single agent systems, but as years progressed from 23 onwards, we've been also having multi-agent systems. So with time, your agentic AI systems are becoming very transformative for recommendation systems. So let's have a look at what basically are, agentic systems. So if I want to put it down there, it would be very easier for me to say that LLMs plus some memory plus planning plus tool use is going to give me a very good agentic system. So, at the heart of any agentic AI, there will be a combination of four powerful components, right? First of all, you're going to have an LLM, which is basically serving here as the brain, because it is going to understand the language, it's going to reason. Secondly, you have memory. Now, why is memory very important here? Because it will allow the system to remember what the user preferences was, what the past user interactions have been. Then we have planning. Now, in planning, it is basically going to enable a system to break down whatever the user goals are into different actionable steps. And finally, tool use, where basically your agents can access search engine, APIs, databases, any of these to basically enhance accuracy and utility. Then what are the core capabilities of an agentic AI system? So they can perceive, reason, act, improve. So together, these components, they enable agentic systems to do what traditional recommendation systems cannot do. Like, these can perceive multimodal inputs, so not just clicks, but we're also talking about text, images, and behavioral cues. Then they can also reason, like through ambiguous queries or long-term goals. Then they can act, like they can make decisions, they can trigger tools, and most importantly, they can learn and improve over time. So these are some very important capabilities which an agentic system would have. Now, what are the opportunities for recommendation systems, with the rise of agentic AI? So first of all, there's going to be continuous adaptation, that agentic recommendation systems can update their strategy in real time based on user feedback. Then there will be contextual intelligence, that they don't have to just react to what the user clicked, but they can interpret the intention behind the user, the timing, the tone, and sometimes even the content type, right? And thirdly, they enable human like interaction. So instead of showing like static lists, the agent can basically have a conversation, it can clarify what your needs are, and it can evolve with you, right? So to appreciate the progression towards agentic recommendation systems, the paper has outlined four levels of framework, that how the recommendation systems have evolved. So here we come to four level evolution of recommendation systems. This is again a table from the paper itself, and we'll be discussing it in a little more detail, that how from static to reactive from static and reactive to autonomous and interactive systems we have been moving on. So first of all, we come to level 0, which was the traditional recommendation system. So at the base, when we had like just basic traditional recommendation systems, they were based on heuristic rules or just simply collaborative filtering, so they're static. They'll be relying mostly on just user item interaction, and they're going to generate just one shot recommendations, without any interaction, without any reasoning. So a few examples for this would be like early Netflix or Amazon recommenders. They were simple item to item similarities, right? Like you've watched one particular um, movie, it's going to recommend you of a similar genre or of a similar actor. So it was just item to item similarity based. Then we have level 1, which is advanced recommender system. Now advanced recommender systems, they bring machine learning and deep learning techniques, right? So now they're using embeddings, they're also using neural networks, and they become a little more dynamic. So now they will be able to incorporate any kind of feedback that's coming from the user, and they can update their representations, but they also still somewhere lack that conversational capability or that deep personalization. So they optimize for clicks but not for context, right? Then we come to level 2, which is basically the intelligent recommendation systems. Now, at this level, basically, we will see that systems become interactive, right? So they can understand like multimodal inputs like text queries, images, and they can, start incorporating the real-time user intent behind it, right? So we can say that they're more smarter, they're more flexible. For example, a voice assistant that can recommend me restaurants based on dietary preference, let's suppose. So that can be a very good example for intelligent recommender system, because it's taking like an audio input, and it's also looking into my dietary preference, so it's very personalized as well. And then finally, level 3 is basically where we see agentic recommender systems, or you can say LLM ARS. So these systems are basically fully autonomous agents. They can like reason, they can plan, they will also be remembering your past interactions, and they will adapt over time, right? So they're proactively engaging with users, they're simulating different recommendation paths, and they're also going to leverage external tools and enhance results. So if we talk about agentic recommender system, they basically mark a complete shift, like from systems which were responding to users to like systems which can now collaborate with them, right? So now that we've seen the landscape, let's focus on what exactly defines an LLM based agentic recommender system. Like, what is it like, right? Let's look at it. So basically, um, recommendation systems are agents which are powered by LLMs, right? So LLM ARS refers to like recommender agents that can be powered through large language models and enhanced with like multimodal capabilities, right? This means that they're not just processing text, but also images, behaviors, structured metadata. Like, it's basically allowing them to understand complex and real world user inputs, right? Then they can also act very autonomously, based on interaction and context, right? So this means that, these agents will be autonomous, and they don't wait for any explicit user queries, right? So instead they monitor interaction patterns, and they'll be learning from your feedback, and they will basically, what they would do is they would proactively generate suggestions that would be context aware and also very relevant to you, because obviously it's in a conversation, it's going to understand everything, it's going to you know be very autonomous. For instance, like they might suggest a new playlist based on your mood for that day, or they offer you some travel deals before even you search for them, right? Then if we talk about what are the core capabilities of an LLM ARS, so such agents, they're equipped with like three very transformative capabilities. First of all, they're going to understand multimodal inputs. So here we're looking at processing like natural language, processing visuals, behavior logs, so it gives them a very more complete picture of what the user is intending to do, right? Then there is basically, they're planning multi-step interaction. So they're not just limited to one single click suggestions, but they can plan like a sequence of steps. Like for example, they can do a book recommendation, then a movie adaptation, and then maybe a relevant podcast. So all of these can be recommended based on the same user goal, right? So they're not restricting themselves to one specific niche. Then collaborating across agents. So LLM ARS can basically work with other agents as well. So it could be interacting with a search agent, with some kind of a summarizer. So like you can integrate it with others to accomplish like more complex recommendations. So if we look at it, so LLM ARS is basically transforming recommendations from like from passive suggestion to like an intelligent and very goal driven interaction, which is powered by LLMs and vision models. Okay, now let's understand the core architecture behind LLM ARS, right? So, in essence, if we look at it, an LLM ARS is not just a recommender, right? It's like a digital assistant that can, understand, that can plan, and like, it can act with intelligence across multiple channels. So, if we break down what makes an LLM based agentic recommender system to work under the hood, the architecture proposed in the paper basically, consists of four core modules, and each with a very specific function that mimics how human assistants normally operate. So the very first one is user profiling. This module continuously builds a very rich evolving profile of the user. So it will go beyond your clicks and purchases. It's going to combine your contextual signals, like for example your time, location, device, and even it's going to infer to goals from conversation, right? So it supports like you can say multi-dimensional personalization. Like it's helping your system anticipate what the user needs accurately over time. Then the next one is planning, the planning module. Now once the user goals or context are understood, the planning module takes over. So it's not just picking the best item, it is basically strategizing. Now it's going to map out like a multi-step interaction plan, like maybe starting with an exploratory recommendation, then followed by some more refined suggestion, and then a call to action. Like that's going to depend on how the conversation with the user is going on, right? So this is what we can say that it is enabling like a goal directed recommendation flow. It is like very similar to how a human assistant would help plan a vacation, or build a shopping cart. So like it's very much similar to that. Then next we have the memory module. So the memory module is like essential for any kind of continuity or personalization, because it's storing short-term session context as well as the long-term user history, right? So this is going to enable the system to recall what you liked last week, or what you rejected, or like what did you ask for 6 months ago. So it's basically allowing for a very longer personalization, and a very deeper kind of relevance. Then finally, we have the action module. Now, in the action module, it's basically responsible for, executing any kind of decisions. So this is where the agent is going to deliver the recommendations. It's going to respond to feedback, and it's going to interact with any external tools when needed. Like for example, fetching some real-time prices, or filtering some options based on current availability. So this is basically the do part of the system. It's making the intelligence actionable. So together all these modules, they form a very closed loop. So they perceive, plan, remember, and act, right? So it's creating like a system which will basically evolve with the user and make contextually intelligent decisions, right? All right, so agentic capabilities that are enabled by LLMs. So with all this potential, it is important to ask that what are the agentic capabilities that we have, right? So, first of all, if we look at it, they can basically plan and reason. So, any LLM agent can basically, break down any of the complex goals that we have into smaller subtasks, and it can also reason. Like, they know your history, they know your context, so they're going to be very coherent in form of giving you recommendations. And then there is a chain of thought prompting, which is basically, going to enable the LLM to, better plan and reason whatever recommendation they're making, right? So if, for example, I have to recommend a movie, it's not just going to be based on just my past clicks, but on my mood, time of the day, and maybe prior dislikes, right? Similarly, tool use as well. So when we talk about, like, agents interacting with like external tools, or like any other APIs, or like any kind of real time price checkers, all of these tools with an agentic LLM is going to, lead to better accuracy, more factual grounding, more relevant results. So, like, if a user is asking for, budgeted flights somewhere, so the agent is going to query the flight API, and it's going to find the prices even before suggesting any other option. So, like, it itself is going to set up that filter. And then there is a multi-agent collaboration that can take place, right? So when we talk about multi-agent collaboration, what happens here is that, you are going to have like specialized agents, like, which are going to be working together. One can be finding some options for you, the other could be adjusting based on the feedback. So all of these different multiple agents can, communicate and share their memory. And that whole, you can imagine this as being like, a team of virtual assistants who are working together and, working to derive the best results. And then we come to, like, simulation and role play. So any agent that we have, it's going to simulate any user persona, right? So it's going to be monitoring what kind of diverse behaviors and preferences are there, and then, what user is like, what kind of user response is coming to the recommendation that it is making. So it's going to tailor it more to be user specific. So it's, very personalized. And training and evaluation can also be done very easily. So, if I want to simulate a teenager or a working parent or anything to, test my recommendations, that can be done as well. So, this is again a diagram from the paper, that how there are different types of personalized LLM ARS, which can, like the first one here can, simulate user behavior and act as a, the second one acts as a recommender, and the third one is basically an agent function, which is, using both user simulation and a recommender system. So, basically what LLMs are doing is that they're equipping, these agents with, like, human-like intelligence. So, like, you can say they're giving this, they have this capability to now think, collaborate, search, and even, sometimes um, try to behave given like behave a certain way given the contextual awareness that they have. Now, in this paper, they've also, raised a lot of key research questions about LLM ARS, because it's such a new concept that, there are a lot of research, there's a lot of scope for research, and there are a lot of research questions that are coming up, right? So, it's very important to us that what are the big research questions and challenges that, we'll have to address, so that we ensure that, agentic recommendation systems are truly effective. So if, so building like an LLM based agentic recommender system is like a very exciting frontier, but it also opens up a lot of research questions that have been identified in the paper. So each of these research questions in bold is going to be a question which is from the research paper itself. So the first question goes about that how can reasoning, planning, and collaboration enhance recommendation system? So basically, how do we leverage the full reasoning power of LLMs, right? So can agents work together collaboratively, or can they break down and solve recommendation tasks? So this question basically touches on how, we can coordinate multi-agent environments and use planning models to derive, long-term user satisfaction. Then the second question is that how can LLMs improve personalization and interaction? So, this basically means that how can large, often pre-trained models can be fine-tuned or adapted for individual users. So basically, this involves balancing general knowledge with personal relevance and figuring out that how we can let users, shape their own experiences through richer interactions. Then, if we move to the next set of questions, so the third question is that what frameworks basically are supporting the autonomy of, such recommendation systems. So, what architectures can support agentic autonomy? So, where systems are acting proactively and not just reactively. So, this can basically, include any role-based systems, feedback loops, or maybe reinforcement-based learning control. Then the next question is how to integrate multimodal reasoning. So, users often communicate with more than just text, right? So they're using images, audios, and even gestures, right? So how can we integrate reasoning, across multiple modalities and fuse them, in a way that can help make the system, make the system to derive better context-aware recommendations. Then the fifth question goes about that how can we evaluate LLM ARS effectively? So because the current recommendation benchmarks, they're not enough, right? So we would need new evaluation frameworks that can account for, multi-turn conversations, coherence, during the conversation, different tools being used, and, even user trust. Like all of these are evaluation benchmarks that can be used for LLM ARS, right? Then the sixth question goes about how to balance autonomy and control. So it's basically, if we're building systems that are acting independently, so how can we make sure that, they stay aligned with user goals? So this question is basically, raising issues around hallucination, safety, and it's ensuring that the agent doesn't go off course, right? And how can we achieve lifelong personalization is the next and the last research question. So, if we build systems that act independently, then how do we make sure that they're staying aligned with user goals? So this question is again, raising um like, this question is basically telling us that how um, you know, we can build systems that will remember, adapt, and personalize continuously, right? So this will actually require, multi-efficient models and incremental learning and, strategies to handle preference drift. So these questions are still being researched upon because this is a very recent research. So it's still underway. All these research questions are still potentially being worked on, right? So this is basically, like a roadmap, which is defining, what kind of advancement and what kind of recommendation systems can be built using LLMs, right? But obviously, whenever something new comes up, it comes with its own challenges, right? So, as promising as agentic recommender systems are, building them, will not come without any significant challenges. So now we'll be highlighting some major obstacles that need to be addressed, to make sure that LLM ARS are practical, reliable, and scalable. So first of all is hallucination. One of the most well-known issues with LLMs is hallucination, right? Because they generate context that sounds plausible but is factually, incorrect or is completely made up, right? So whenever we have like a recommender system, this could mean suggesting items that don't even exist, or they're not even available, or maybe they're entirely, irrelevant. So, hallucination can be particularly very dangerous in domains like health, finance, travel, like anywhere where real time accuracy is critical. So, hallucination can be a big problem. Then controllability. Now, because these systems are very autonomous, so controllability can become a very core concern. So, how can we ensure, that the agent will not go too far in making decisions that, are not aligning with what your user has set as the goal? And this can also include, that user override mechanisms that, might provide explanations and, ensure that users can guide or correct the system when needed. So we need to introduce some kind of controllability there. Then comes efficiency. Now, multimodal LLMs are very computationally expensive. So, when you're running such systems at a scale, like let's suppose for millions of users, while also supporting like real-time reasoning, tool use, memory access. So it's, a very major engineering challenge, because efficiency techniques like, model compression, hybrid architectures, or prompt optimization, they're all needed, to make sure that these systems are ready to be deployed in production. Then evaluation is also a challenge, because traditional recommendation system metrics like precision or recall will not be enough, right? You will have to evaluate the quality of the conversation, then long term engagement, how adaptability is working for your LLM ARS, and is if it is trustworthy enough. So creating like standardized benchmarks for these new behaviors is like a very wide open area for research at the moment. Then finally, bias and safety, right? So lastly, because LLMs are like trained on very large and unfiltered data sets, so they might reflect or amplify biases, right? And that might even produce some unsafe recommendations. So ensuring fairness, transparency, and ethical alignment is very essential, because it- because these systems will interact more naturally and proactively with users, right? So, if we talk about these five challenges: hallucination, control, efficiency, evaluation, safety, they all must be addressed very holistically as we move on to building more powerful and agentic recommenders, right? Now, there is a proposed framework in the paper itself which suggests that what can be used for building LLM ARS, right? So there are basically three main frameworks for building LLM based recommender system. First of them is single agent systems. So, one central LLM, it will handle all tasks like perception, reasoning, planning, action, right? So it will be simple and unified, but it will be hard to scale or hard to specialize, right? For example, just one GPT agent, which is managing all user interactions and recommendations, right? Then we have multi-agent systems, right? So there will be multiple specialized agents working together, and each of the agent will be focusing on a specific role like searching, ranking, explaining. So, this modular approach is going to, help us in improving scalability, parallelism, and, but here we will need to, make sure that there is good coordination between all the multi-agents. So, for example, there are different agents which are retrieving, there's different agents which are ranking and explaining the items, right? Then the third one that we have are human LLM hybrid systems. Now, for humans to provide oversight and feedback, ensuring alignment and trust and ethical use, so the system will adapt based on user input. Like, for example, there is an agent which is suggesting, recommendation, and the user is going to refine them, right? So in short, these frameworks will evolve like, from single centralized agents to collaborative multi-agent setups, and then, human in loop designs, and then, it's basically like adding layers of intelligence and safety slowly and gradually, right? Okay, so coming on to the key takeaways, like, let's highlight the main points about LLM based agent recommender systems, right? So first of all, LLM ARS, they represent the next generation of recommendation systems. So it's going to combine large language models, agent like autonomy, and multimodal interaction. So we are basically moving beyond the traditional systems to offer like, a proactive and context rich engagement. Secondly, agentic recommender systems, they're bringing true intelligence and autonomy. So they understand user intent and context, across images, text, behavior. Then they're also continuously learning from feedback, right? And they're basically interacting naturally, using language, audio, vision. And thirdly, LLM ARS, they are bridging the gaps between static models and dynamic real-time systems. So unlike the traditional recommenders, which are limited by fixed inputs, uh, these systems, they can act, like intelligent assistants that can also perceive, reason, and even respond instantly, right? So to sum it up, I would say that LLM ARS is not just a better recommender. It's like, a smart and adaptive agent that is evolving with the user needs to, deliver very meaningful, contextual, and ethical recommendations. So if we come to the conclusion of this, so recommender systems are basically, in the future, they're not just going to suggest, they're going to, understand your perspective, they're going to converse with you, they're going to adapt as per your need, and they're going to grow with us, right? So this is the vision behind agentic recommender systems. So that brings us to the end of this. Feel free to connect with me on LinkedIn, and I'm opening it for any questions. Um, Okay, I'll share the paper name with you all. Okay, so this is the paper that we basically went through towards agentic recommender system in the era of multimodal LLMs. If you want, I can also share, like, a PDF copy of this. I can share it with TFUG team, and they can share it on the group maybe if everybody wants a copy of this research paper.
Yeah, sure. Thank you so much.
I'm open to questions if there are any questions.
Ma'am, what would be the cost for the APIs and if I have to implement one of these systems? Can you kindly tell about the cost?
For the cost, you'll have to check, which API you want to use. Like, there are different pricings with different APIs, and, they're based on the number of tokens. So the pricing will matter on your use case, that how many tokens you require, which model or which API you're requiring. So you'll have to check the
Okay,
pricing. I cannot give you one specific amount
okay,
here.
got it. It's a broad question.
All right. Any other questions? Okay. First step for developing agents. You're asking for general agents, or are you asking for, like, LLM based recommendation system agents?
Ma'am, LLM based recommendation systems probably are multimodal.
Okay, so you're asking, like, what is the first step to develop it? So, first of all, you'll start with integrate. See, again, if you want to go for an agentic AI system, I shared here, like, the steps to it, that what exactly we need. I'll revisit it again. So basically, if you need any agentic system, you just need four things, right? First of all, you need an LLM, so you can use any API of any LLM that is already available to us. Then you would need very good memory capability. You would need good storage so that you can have your own way of storing the data that is coming up with the user interaction. Then you also need some planning, like, you need to have, like, a setup which is going to basically, be able to strategize whatever task at hand is into multiple steps. It's going to break down into different steps, and it's going to go one by one, solving each step, right? And tool use. When we talk about tool use, there should be any kind of third party app or any kind of API connected. So, like, my recommendation system or my LLM based recommendation system would be connected to the search engine, or would have those capabilities to go and search, so that it basically derives its answers based on all of these components.
Okay, my question is like with the levels of recommendation systems that you said earlier,
Yes,
level one,
yes,
level two, and level three.
yes.
So what makes us go from level two to level three? Because again, the recommendation systems that we had, let's say the classical machine learning methods, uh, could be decision trees, could be any clustering, or any deep learning model, which
Yes.
which which can have like parameters lower than 100 millions. And
Yes.
for large language models, we are supposed to have 7 billion and like so on, uh, just for it to have the context and uh, the ability for agents to interact,
Yes.
right? So don't you think that's like a very big trade-off between cost and what we are trying to achieve? Like,
Again, see, when you're talking about, see, if you're using and if you're integrating an LLM API, right? So again, see, whenever you're talking about what parameters or what kind of system you want to build, you look at what use case you have and what resource capacity you have, and then you design your entire use case, right? That what kind of LLM am I going to use, what, like, what is the problem statement, like how much accuracy do I need, how much context awareness do I need, right? So you look at your use case and then you have to decide the trade-off, that what is more important to you given that specific use case, right? So it's going to vary problem statement to problem statement. Okay, I have a question here, that please describe the difference between generative AI and agentic AI. Okay. Now, generative AI is where we're generating any new thing, right? Like, for example, when you go to Chat GPT and you ask it to, generate you an image or a diagram of XYZ, right? If you give it a prompt to generate you an image, it's going to generate something new and give it to you, right? Agentic AI is where I set up an agent, I give it a number of steps, and I ask it to perform that for me. It's going to do it itself, right? If I like set up an agent, let's suppose that, whenever a new user comes in and enters their details, I want you to generate an avatar for them based on the details they've entered. So then agent is going to automatically do that for me, right? So in agentic AI, we're basically incorporating agents. We're basically trying to automate it in a number of steps and making the agent work on them. And generative AI could be just, generating anything in any capacity. Does that answer your question? Um, the question of Tesla car using agentic AI, that is basically, if we go a step back, when AI initially came out, so there have been, like, rule based agents, and such kind of different agents were always there, which basically followed some steps. Like, there was reinforcement reward based agents, then there were rule based agents. So all these systems have been there. Now, what Tesla uses, it's going to be a very advanced kind of mechanism, right? But if you want to understand at the baseline, then yes, we can say that it uses simple agents as well. Any other questions?
Assalamu alaikum, ma'am.
Walaikum assalam.
I have a question that whenever we create this type of agents, we face the issue of efficiency. We have latency, and when we are using external tool costs, we face too much latency. So, how can we cope up with these latency and efficiency issues?
Okay, so it basically depends on your whole architecture. If there are latency issues coming, then you need to look at your architecture and, move towards a more lightweight overall architecture. Like, for example, if you want to like build different agents. So right now there are like a lot of tools available which you can leverage. Like, for example, there is a tool called N8N. Now, N8N is basically, a whole platform which provides you with, designing your own AI agents. You can design an entire AI workflow using different agents, and they're all basically node based. So you're just going to, pick up different nodes and configure them, and, set their prompts, and you can have an entire workflow ready, right? So try leveraging, if your use case is small and if you're just doing it for the purpose of learning, start with small tools and see how basic architectures are working, right? Because latency issues come when your architecture is, too huge, or maybe, not compatible to the fullest. That's why it's taking time in communicating, right? So you should, I would say that you can leverage such tools to make sure that your system or your architecture is more feasible.
Yes, ma'am.
Okay. And when we talk about the context that it learns, the agents and that they give it to the LLM, what context are we talking about? Because like as for the user information about their age or their interests and stuff, we can also get that from with machine learning and deep learning approaches freely.
Yeah, but context here could be meaning, it could be, could be like, if for example I'm asking about a particular genre, okay, or let's suppose I'm asking about, um let's suppose I want to find a new movie which is, let's suppose, an action movie, but it is also not very long. And I personally enjoy movies which have, like, I am basically giving it so many different specifications which are only relevant to me. They're very personalized. So all that context, it's going to keep it in mind, and it's going to recommend based on that. If you go for traditional machine learning, deep learning approaches, they do not have every, like, they are going to work on specific, you can say, specific kind of niche or specific categories that
Yeah,
are given to them, right? They're not going to cater to every single context that is there. But if you have an agentic recommendation system powered by LLMs, then it will be capable enough to cater to all the user needs that are there.
right.
Does that answer your question?
Yeah, thank you.
All right.
Samika?
And another question is that have they provided the authors, have they provided any justification for the cost? Because if it gets implemented in a commercial platform, uh, like let's say Netflix and maybe Daraz and Amazon, how are they going to cater it? Because I think every click is going to trigger the agentic workflow, and that leads to LLM prompts and stuff.
Here, see, this is again a research, right? When we do a research paper, we do it purely for the purpose of research and for advancement in research. A
Okay.
research paper is not written for a commercial point of view, right? Like, not every research paper has like a commercial aspect attached to it.
Right, right.
So, in this paper there was no such discussion, but you can have a read, and you can, if you want to know more about it, you can reach out to one of the authors.
Definitely. Thank you.
All right, any other questions?
I have a question that when we have too much data, then how we can feed that too much data in a context, because we uh, run out of context limits. So if we have too much data for a user, related to user, then how can we feed this in a context uh, to get recommendations regarding anything?
See, there are LLMs, right? And it's a dialogue based system. So how, just like when you're talking to chat GPT, if whatever output is coming, if you want it to be changed, if you want to add something more, if you want to change the tone of it, if you want, it to answer in a different direction, you give it a prompt again and again, right? So you're giving it more and more context, and it's able to deal with it, right?
Yeah, and
Yes,
I
ma'am.
think the recent the LLMs, right, but the Geminis and the recent Geminis that are available at AI Studio, they have a very big context window. So I don't think if like we should worry about context